Look around any modern city, and the sheer physical weight of the infrastructure is staggering. We watch massive concrete pillars lowered into place for highway overpasses, and we see miles of steel locked together to form grids and bridges. But long before the first foundation was poured or the first beam was welded, the exact parameters of that physical reality were determined by a quiet, unseen process. Almost every major road, a power plant, and transit court you interact with went through, or was legally required to go through, an environmental impact assessment. The physical permanence of steel and concrete begins as invisible policy documents. This mechanism governs the largest interventions humans make on the landscape, specifically dictating the scale and limits of power plants and heavy transit ports. Over the next several hours, we will dismantle this normally opaque process, step by step, so you can understand exactly how it works from the inside out. Understanding this sequence is the first step towards seeing how technical assessments translate into the physical layout of our cities and ecosystems. To do that, we have to look past a common misconception. Many view an environmental assessment as a simple exercise in bureaucratic compliance. Often, the term assessment is misused to describe a static form filled out after a design is finished. But a credible EIA is a predictive argument about the future, constructed with empirical evidence during the planning phase. Timing is critical. The argument is only effective if presented early in the timeline, while variables like location and technology are open. If it arrives after paths have locked, the document serves no technical purpose. The decision is finalized. When executed early, a strong assessment carries the weight to halt a project with unmanageable costs or force significant engineering upgrades. It also provides a structured mechanism for stakeholder agency, allowing the local populations who will live with the project's consequences to see the data and provide formal input. The strict timing of this process determines whether an EIA results in substantive environmental protection or simply functions as paperwork arriving after the decision. Every credible assessment follows a universal 9-step architecture, regardless of the jurisdiction. We will explore this framework across 6 distinct modules, representing roughly 12 hours of deep structured learning. The sequence begins with screening. This acts as the initial filter, determining if a proposed project even requires an assessment in the first place. Next is scoping. This phase establishes the strict analytical boundaries and the specific environmental concerns the assessment must cover. There is a sequential dependency here. Practitioners screen out unnecessary projects so they can properly scope the parameters of the necessary ones. Once the boundaries are set, we move to baseline studies. This captures the absolute empirical state of the environment before any human intervention occurs. Gathering highly accurate baseline data is non-negotiable. It provides the control against which all future stresses will be measured. These first 3 steps form the indispensable factual foundation. Without them, the rest of the architecture collapses into mere guesswork. With the baseline established, the assessment shifts from gathering foundational data to active predictive modeling. Step 4 is predicting impacts. Practitioners use the baseline data to model the specific future footprint and ecological stress the proposed infrastructure will exert. Then comes weighing. We evaluate the severity, scale, and probability of those predicted impacts. This introduces an inherent tension into the process, requiring practitioners to balance projected economic benefits against highly quantified ecological costs. Step 6 is mitigation. This is where specific engineering safeguards and design alterations are created to neutralize the predicted harms, feeding directly back into the project's original design variables. Step 7 is monitoring. A plan must be established to enforce and verify that those mitigation strategies actually succeed over a decade or more. Step 8 is public consultation. This formal mechanism exposes the data to the affected community and forces the integration of their direct feedback. Finally, the decision. The preceding architectural logic legally culminates here, determining the final approval, modification, or rejection of the project. Steps 4 through 9 represent the active engine of the assessment, transforming raw scientific data into legally binding physical reality. Moving from an abstract 9-step framework to implementing it reveals a messy empirical reality. To ground this, we will use India's specific system as a recurring empirical model throughout the course. India illustrates both the significant systemic promises and the deep bureaucratic frustrations that occur when these tools are applied. While local politics and specific regulations fluctuate, the underlying analytical logic remains consistent across different geographic boundaries. Whether you're navigating regulatory jurisdictions in Pune, Nairobi, or Toronto, the underlying math, science, and sequence remain identical. Mastering the logic in one jurisdiction equips you to systematically evaluate infrastructure anywhere on the planet. Let's transition to the practical mechanics and expectations for the rest of these modules. The division of labor is straightforward. The video lectures will provide you with concise, conceptual frameworks. They are intentionally kept short. The mandatory readings provide the deep dive technical mastery required for real-world application. They matter, and skipping them will severely limit your progress. Project-based learning is the core mechanism for synthesis in this course. Starting in Module 3, you will step into the role of a practitioner and build a custom assessment of your own, piecing it together one technical component at a time. You will then submit this assessment to a peer review mechanism. Having your work reviewed by others closely simulates the intense stakeholder scrutiny you will face in the field. Therefore, your first task is to immediately select a complex, compelling, real-world infrastructure project to focus on. Pick something that holds your attention. Sustained focus on a single project is the only way this theoretical knowledge will translate into practical intuition. Mastering this invisible architectural process is the first necessary step to actively redesigning our shared future. Let's begin.